Hello and welcome to session number 11. And today we're going to talk about soil analysis. What do you get out of a soil analysis? Okay? But just a little recap, if you don't mind. In the soil, there are the solid components, which are comprised of the minerals and the organic matter. The rest is air and water. So let's forget about these for a while because they don't affect your chemistry much, your soil chemistry. Now, so the mineral component is very important in deciding everything. Why? Because that mineral component is derived from the original parent material, the rock from which that soil was produced. You will never find two rocks that are exactly the same. Never. You may call something basalt, feldspar, mica, whatever. You can give it any name. But you will never find two rocks that are exactly identical. Why? Because there is a major, and I'm not a geologist, I'm not claiming to be a geologist, but just like you cannot find two people who look exactly the same, or two clouds, for that matter, that look exactly the same. You will not find two rocks that are exactly the same. They will have a lot of basic common features, but there's a lot of little things there, impurities inside of them, that will make them all slightly different from each other. And this is why you will never find, perhaps, the perfect parent material rock that is going to produce a soil that has all of the essential elements that a plant needs in any given situation. Makes sense. And even if it does have them, it's not going to have them in the right ratios that the plant, or plants, if you have different crops, need them. Because different crops, even though they all need the same essential elements, but they will need them in different ratios. So to have this perfect soil is virtually impossible. This is something very important to remember, because in any given situation, if you put your soil and environment under a bubble, okay, and prevent anything that's got to do with any input or output, every solid in your soil, every solid component, including the organic matter, is going to be based on the original chemistry of the original parent material from which the mineral component was derived. What does this mean? It means that if your soil, let's say, is deficient in zinc, and many soils are deficient in zinc, it means that it has been derived from parent material that is deficient in zinc. It also means that everything growing on it is also going to be deficient in zinc. It means that the grass and the organic matter it produces over here is also going to be deficient in zinc. So if you are going to expect the organic matter that your soil produces to have enough zinc in it to support your crop, then you're really barking up the wrong tree. Unless you apply that zinc, it's not going to be in amounts that are sufficient for your crop to grow. Now, having said that, it's almost impossible to put this bubble around any given situation, because you always have a little bit of give and take. You got birds dropping, contributing to, the input in your area. You've got wind, you've got dust. All of these things settle, albeit small amounts, but they can make a contribution. But this doesn't mean that we can rest on our laurels and expect that those little contributions are going to be able to solve major deficiency issues that our soils have. So we have to establish what are those major deficiencies issues and address them. And unless we're able to add these things artificially, when I say artificially, I mean manually ourselves, zinc, we have to apply it. If we don't, then everything we grow here is going to be deficient in zinc. So this fuzzy, sorry, I don't mean to be rude, but this fuzzy attitude about using compost, producing your own compost to grow things in doesn't really go very far if your soil is deficient. Again, we're talking about zinc. And I can only give examples here about Australia. I can give examples about other parts of the world, but I will restrict my examples to Australian soils, otherwise, we'll be talking forever. Soils of the entire eastern seaboards in Australia are primarily deficient in zinc, boron, and molybdenum. Now, the funny thing about molybdenum is that many consultants, growers, gurus that I have seen and spoken to and read about and listened to don't even mention it. They don't seem to even know about it. Molybdenum is an essential element, I mentioned it before, without which plants cannot grow. So you can rest assured, if you're on the eastern seaboard, then your soils are going to be deficient in molybdenum. And some soils in the eastern seaboard are deficient in manganese, which is quite unusual because normally, parent materials have enough manganese in them to liberate, to mineralize if the soil is acidic. Okay, that's a condition. Two conditions actually. They have to have manganese in the parent material, and then the soil is acidic. Now, in the Australian eastern seaboard, we meet one of these conditions. The soils are acidic, but if there's no manganese in the parent material, it's not going to be there in the soil. So you will find many pockets, even in some places like, say, Bundaberg. I'm just giving an example. You will find blocks that are high in manganese, close to other blocks that are low in manganese. Why? Because it all depends on the original parent material. Let's remember that. It's very important. So what do you get? What do you get when you do a soil analysis? What's the information you get? It's important, but it doesn't tell you everything that can be known. There are some basic figures that you will find that you need to get in any soil analysis. The most important of which is the pH, because the pH really decides the level of availability of essential elements, because some go up or down with changes in pH, and we'll talk about this later on, not today. And then you've got the salinity, and this can be expressed in different terminologies, either by saying EC, referring to it as EC, which stands for electroconductivity, or TDS, which is total dissolved salts. Now, let's not get bogged down into details. The bottom line here is that these essential elements are good for the plant, of course, we know that, but too much of them, or too much of others that are not really needed, like sodium and chloride, will create salinity problems. And it is very important to know what is the salinity of your soil. Now, I will be advising later on, I'll be advising of how to make simple tests, things that you can do yourself to sort of like get a rough estimate about these things if you can't or don't want to send, a soil analysis to a lab, especially if you're a small gardener, right? So bear with me. Okay. The third one is organic matter, and that's something, again, you can sort of easily measure at home in your kitchen, and I'll show you how. And the last one is the CEC, or the cation exchange capacity, which we talked about previously. Okay? So these are things that come with your soil, like the color of your hair, like the color of your eyes. You can do some changes about them, especially the pH. If your soil is acidic, you can reduce this acidity, okay? But all these other things, you can move around a little bit, but not much. Remember what we said yesterday, that 1% of the weight of your soil is 20 tons. So if you want to increase your organic matter, let's say by 1%, you have to input 20 tons of organic material into your soil per hectare. but that's on dry basis. Okay, and how much moisture there is, let's say in manure or grass and compost, 80%, 90%. So the 20 ton you'll have to increase by 4 or 5 fold to get the amount of organic matter you need to raise the organic matter content by 1%. And you're talking about 100 ton. Now, who can do that? Realistically, you can't do it. We will be talking later on, again, not today, about how to manage organic matter and how to build it gradually and slowly into your soil. Okay, so apart from these things that you really have to take and accept as they are, as given, what does the soil analysis provide you with? It tells you the levels of major elements. But this is not the total levels that you will find here in the mineral fraction. Okay? It's only giving you the amount of minerals that are available to the plant, or that we believe are available to the plant. There are methods of extraction that are believed to simulate the ability of the root. So when you look at these levels, you'll get a good idea about the levels of major elements that are available to your crop, and also the levels of trace elements. Trace elements, by the way, is a misnomer. Trace means rare. They really are called micronutrients. In science, they're called micronutrients, but never mind. This term is the one that's widely used, so we'll continue to use it. So in the soil report that you get, you'll get figures of those basic things that you need to know, and then you get an idea about the minerals that are available to the plant. And based on these things, you have to make a decision. What is it that you need to have? Okay? Now, if the soil analysis tells you that your soil is lacking on zinc and boron, then you cannot depend entirely or even remotely on any compost material that you have generated on your property. You will have to get, if the input is going to be organic, it has to be from an area that is high, that is derived from parent material that are high in these minerals. And the likelihood of you sourcing this locally is virtually impossible, because you'll find that all of the local areas will have the same problem as your soil. So you really have to bring this in from outside. And there's nothing wrong in doing that. I will explain in later sessions that it's okay, safe, and proper to import these things from outside and use them on your property in order to make sure that your crop is adequately nourished in terms of trace elements. Thank you for listening.